Hello students, welcome back to our channel Learn from Born Teachers. We were discussing about states of matter topic from chemistry. In the first class, we dealt about introduction and we started the intermolecular forces. Already we knew there are 4 types of intermolecular forces that we are going to deal in this chapter. Dipole-dipole forces, dipole-induced dipole forces, dispersion force or London force, and the last one, hydrogen bond. First three together we will be calling as van der Waals forces. In the last class, we studied about dipole-dipole forces. Moving to dipole-induced dipole forces. The heading itself is giving you the idea. It is the interaction between a polar molecule and a non-polar molecule. What is polar molecule? A molecule which is separated by charge. Non-polar molecule, there will not be a charge separation, or we can say mu or dipole moment is equal to 0. When they come close together, the positive charge will pull the electrons of the non-polar molecule towards itself, so that there will be a charge separation in non-polar molecule. So what this polar molecule is doing, it is inducing charge to the non-polar molecule. That is why we are calling it as dipole-induced dipole forces. The definition is here as it is an interaction between polar molecule having permanent dipole moment and a non-polar molecule having zero dipole moment. The example is ammonia and benzene. You know, benzene is a non-polar liquid and ammonia is a polar molecule. So the interaction between these two we can consider as an example of dipole-induced dipole interaction. Interaction energy. We have discussed about interaction energy in dipole-dipole forces as well. Here, interaction energy is directly proportional to 1 by r power 6, whereas r is the distance between two molecules. The likelihood of a dipole moment being induced depend not only on the strength of the dipole but also on the polarizability of molecule. So likelihood of dipole moment is depending on the strength as well as the polarizability of molecule. What is polarizability of molecule? Yeah, let's see. It is the ease with which electron distribution in the molecule can be distorted. It is a measure of how easily electron cloud is distorted by an electric field. Larger the number of electrons and more diffuse the electron cloud in the molecule, then greater will be its polarizability. So that is what the polarizability is. Measure of how easily electron cloud can be distorted. Then we'll move to dispersion forces or London forces. They are attractive forces that arise as a result of temporary dipoles induced in atoms or molecule. How comes the name London? This is London. This is the person who is the reason behind this London force. It is the attractive force between two temporary dipoles of atom or non-polar molecule. We can easily say that it is an attractive forces between two non-polar molecules. See, this is what your non-polar molecules. I have taken two non-polar molecule. We will be analyzing how the charge is getting induced in these non-polar molecules. At a particular instant, the charge cloud is more on one side than the other side, result in instantaneous dipole. At one particular moment, what is going to happen? See, your electrons are here. At some particular point, what is going to happen? These electrons will be coming in such a way that they will be in a particular side, so that you can see now the electrons are on the right side, so there will be a negative charge there, and simultaneously positive charge will be there on the other side. Now if another nonpolar molecules come into contact with this one, what is going to happen? A charge separation will be induced. So this is the weakest force among these intermolecular forces, and you should remember it happens only at one particular instant. So that we'll be calling it as instantaneous dipole induced dipole interaction as well. So there are three names: dispersion forces, London forces, and instantaneous dipole induced dipole interaction. The other kind of interaction and the last one is hydrogen bond. The bond formed between hydrogen of one molecule and the electronegative element of other molecule, that is what we are calling it as hydrogen bond. But whether all electronegative elements will form hydrogen bond? No. Only fluorine, oxygen and nitrogen will form hydrogen bond. As per NCERT, they have mentioned clearly it is a special case of dipole-dipole interaction. Hydrogen bond is found in the molecules in which highly polar NH, OH or HF bonds are present. But you should know that sometimes Cl also makes hydrogen bond. Like for example, like this chloral hydrate, you can able to see the hydrogen bond. Now think about that. What will decide the state of system or a substance? What decides whether this is gas, liquid or solid? So it is intermolecular forces and thermal energy. What is thermal energy? It is the energy of body arising from motion of its atom or molecule. Energy of body arising from motion of its atoms or molecule. If thermal energy is more, what is going to happen? Molecules will be having more energy, so they will attain the kinetic energy, so they will be easily escaping, so that they will be having a tendency to have which state? Gaseous state. So you can able to see that if your intermolecular forces increases, it will be in a solid state. If there is more thermal energy, then it will be in gaseous state. So what is the relation between intermolecular forces and thermal energy? Intermolecular forces are inversely proportional to thermal energy. Okay, so this is all about the intermolecular forces. Remember what all the intermolecular forces we have studied? Dipole-dipole forces. It is the attraction between polar molecules. Dipole-induced dipole forces. It is the attraction between polar molecule and non-polar molecule. What about London force? It is the attraction between non-polar molecules. Hydrogen bond. Remember, hydrogen bond is the strongest among these bonds or these interactions, you can say. Hydrogen bond. It is the interaction between hydrogen of one molecule and electronegative element of other molecule. This is all for today. In the next video, we'll be discussing about the gas laws. Don't forget to share, subscribe and like the video.